Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today simplifying complex numbers. So in simplifying complex numbers, we're going to consider some concepts like square root of -1 and real numbers. Okay, so let us see the examples in our problem set. Okay, here's the problem set, the other screen. All right, so we have here the lecture examples, and we're going to solve it one by one. And this is going to be about how many numbers. So let us see how many numbers. This will be about 24. Okay, so we're going to start doing the first number in the presentation view. Okay, here's the first number. All right, so we're going to simplify. Okay, we're going to simplify this particular number. Okay, and this is considered a complex number. In particular, this is an imaginary. This consists of an imaginary number. Okay, which is the I. Okay, so now let us have a few discussions about this. Let's consider the imaginary number I. Okay, the imaginary number I, and this is equivalent to the square root of -1. Okay, so the imaginary number I is equal to the square root of -1. So if you consider I squared, that means I times I times another I, which is actually equivalent to square root of -1 times square root of -1, which is equal to square root of -1 squared. There. And therefore, the square root and the squared cancel each other because this is supposed to be equal to -1. The square root symbol means 1/2, raised to 1/2, like that. The square root symbol. Now, squaring this, when you square this, that means this 2 and the 1/2 will be multiplied. These are the exponents. So this is equivalent to -1 raised to 2 over 2, which is equal to -1 raised to 1. And so that is equal to -1. Therefore, I squared is equal to -1. Now, how about I cubed? Okay, how about I cubed? How about the I cube? I cube is I times I times I. Okay, and this simply means I times I squared. I times I times I. This is also equal to I squared times I. Now, we know very well that I squared is -1. It's over here. So that means we can replace the I squared with a -1, and we have -1 times I. Therefore, we know what I cubed means. That means -1 times I, or simply negative I. There. So I cubed is -I. There. Okay. How about I to the fourth? Okay. How about I to the fourth? Well, let's have another screen for that. Okay. I to the fourth is equivalent to I times I times I times I. And that can also be simplified I squared times I squared, like that. But I squared is -1. So that means this is -1 times -1, like that, which is just equal to a positive 1. So therefore, I to the fourth is +1. There. Okay, now I'm going to show you that this is cyclical. Okay, there's a cycle. Okay, there's a cycle. So this is every four uh, i's. Okay, every four imaginary. All right, so just remember I is imaginary, and then I squared is negative 1, I cubed is negative I, and I to the fourth is positive 1. I, of course, is equal to I. There. Now, I to the 5, that will be going back to I. Okay? All right, I'll show you. Okay, this is going to be this way. You have you have I squared, you have I cubed, you have I to the fourth, you have I to the fifth, I to the sixth, I to the 7, I to the 8, I to the 9. Okay, all right. I is, of course, I. And then I squared is negative 1. I cubed is negative I. I to the fourth is positive 1. That's I squared times I squared. So it's negative 1 times negative 1. Okay. Now, you can easily see this. This is I to the 1, I to the 2, I to the 3, I to the 4. Okay. Now, I to the 5, you're back to I. You're back to I there. And then I to the 6, this is negative 1. And then I to the 7, this is negative I. And I to the fourth is positive 1 again. I to the 9, you're back to I. There. And then I to the 10, that's another negative 1. And so forth and so on. So it's cyclic. Okay. Every four i's. Okay. So I squared, I to the 3, I to the 4. That will be this equivalent. And then the next one, I to the 5, I to the 6, I to the 7, I to the 8, it's the same. And then you're going to have again the next four. I to the 9, I to the 10, I to the 11, I to the 12. It will be the same. There. Okay? So it's cyclic. All right? So we'll be able to deal with this later. All right. So let's start with the very first number here. Then we will have to use this later. All right. So what is the simplified version of square root of negative 36? Okay, square root of negative 36 is just equal to the square root of negative 1 and the 36 there. And so you can split the square root, and this will be a square root of negative 1 times square root of 36 there. And so this is equal to I, and the 36 square root of 36 is 6. But you have to write this using the real number first, 6i there. So the answer is 6i. That's how to simplify that square root of a negative number. And so this is the answer, and we shall be able to verify that. There. So the answer is 6i there. That goes to our first number. Let's continue with the next. Let's have the second number. Okay, let's have the second. This is just simplification. Okay, we have here a square root of negative 121. So our requirement here is just simplify. Simplify the square root of negative 121. Now, 121 has an exact square root, which is 11. So you can actually write this like 121 times the negative 1. There. And you can split the square root of 121 and times square root of negative 1. Okay. We very well know square root of negative 1 is the imaginary number. So this will be square root of 121, that's 11. Square root of negative 1 is the I. So the answer is 11i. Okay, that should be the simplified version. So it's 11i, and I can show you the answer here. There. Okay, next, number 3. Let's have the third. Okay, here's number 3. Plus or minus square root of negative 49. What is plus or minus square root of negative 49? This is plus or minus square root of negative 49. And this is plus or minus square root of 49 times negative 1. There. And this is also equal to plus or minus square root of 49 times square root of negative 1. Okay. And this is equal to plus or minus 7i. There. That's the equivalent. And we can verify the answer. Okay. So that's plus or minus 7i. Now, how come you can split the numbers 49 and negative 1 to 2 square roots? We actually have that from our algebra rule. The square root of a times b is equal to square root of a times the square root of b. So if you have the numbers 49 and negative 1 inside as radicand, you can split that to 2 square roots. So that's why we have square root of 49. It's over here, and square root of negative 1. It's over there. And that gives us the answer over here, plus or minus 7i. Let's have number 4. Okay, let's have number 4. Okay. Here's number 4. Square root of negative 81. Square root of negative 81. So that means we have a negative 1 there and an 81. So this is square root of negative 81. This is square root of 81 times negative 1. And this is equivalent to 2 square roots multiplied together. And so square root of negative 1 is the imaginary number. Square root of 81 is exact 9. So that means 9i. And that's the answer. 9i. Okay, so we can check that over here. All right, 9i. There. Next, number 5. Let's consider the next number. It's number 5. Here we have to simplify square root of negative 100. Square root of negative 100. This is equal to square root of 100 times negative 1. There. And so we have two numbers inside the square root. We have 100 and negative 1. We can split this to square root of 100 multiplied by square root of negative 1. And so square root of 100 is exactly 10. Square root of negative 1, that's the imaginary number. So the simplified equivalent is 10i. And we can verify that over here. There. 10i. There. Okay. Next, number 6. Let's proceed to number 6. Here's number 6. Negative square root of negative 16. Okay. Negative square root of negative 16. So what we have here will be negative square root of negative 16. This is equal to negative square root of 16 times negative 1. There. And this is equal to negative square root of 16 times the square root of negative 1. And this is now equal to negative square root of 16 is exact, and that's 4. So we have a negative 4 times I. Square root of negative 1 is I. There. All right, that's simple. And we have the answer, negative 4i. And we can verify the answer. It's over here, negative 4i. Let's now continue with number 7. Let's have number 7. Okay, here's number 7. Simplify square root. Simplify square root of negative 144. Okay, this is equal to square root of 144 times negative 1. And this is equal to square root of 144. We can split this to two square roots being multiplied together. There. And 144 has an exact square root. That's 12. And square root of negative 1 is the imaginary number I. So this is 12i. And we can verify that over here. That's 12i. There. I hope you're getting the way to do it. Let's have number 8. Let's have number 8. Okay, next, number 8. 11 times square root of negative 81. How do we simplify 11 times the square root of negative 81? Okay, this will be 11 times the square root of negative 81. And this is equal to 11 times square root of 81 times negative 1. There. And so this is 11 square root of 81. We can now split this to square root of 81 times square root of negative 1. There. And so we have the 11 that will remain 11. The square root of 81 is 9. The square root of negative 1 is the I. And so we have here 99 imaginary. There. 99i. Okay, check. All right, that's 99i. There. Next is number 9. Let's consider the next one. All right, let's consider the next one. Okay, here's the next. Number 9 is 3 times the square root of negative 9. Simplify. Simplify 3 square root of negative 9. Okay, this is equal to 3 multiplied by square root of 9 times negative 1. There. And so we have here something like 3 times the square root of 9. We can now split this to two square roots. There. And 3 remains 3. And square root of 9 is now 3. Okay. And this is supposed to be multiplied. And this is also square root of negative 1. That's the imaginary. So we have 3 times I, which gives us 9i. There. Okay. And so the answer here must be 9i. There. Okay. All right. Over here, you can see the red number or the red writing. Okay. So that's the answer. All right. 9i. So that goes to our number 9. Let's continue with the next number 10. Number 10. Okay, here's number 10. Negative 2 square root of negative 16. Okay, simplify negative 2 square root of negative 16. So this is negative 2. Let's copy the problem. Negative 16 there. Okay, so this remains negative 2. This is now square root of 16 times the negative 1. There. And so we will split the square root to two square roots. We will have square root of 16 times the square root of negative 1. So the moment you have that square root of negative 1, that becomes I. Okay. So this is now negative 2 times the square root of 16, which is exactly 4. That means this is 2 times 4 now. Okay. Negative 2 times 4. And we have square root of negative 1, that's imaginary. Simplifying further, that is negative 8i. Negative 8i. There. And so this is the simplified version of the given. And so we can verify the answer. All right, over there. You can see the red answer over there. Okay, negative 8i. So I hope you're learning from the method. Okay, if you encounter this, you should be able to simplify it. Let's have number 11. Let me clear the screen. Number 11. Here's number 11. 16 minus square root of negative 16. Okay, 16 minus square root of negative 16. Let us simplify. We have here 16 minus, all right, square root of negative 16. We can split this to two square roots. The square root of 16 multiplied by square root of negative 1. But before that, let us just get the factors first. Inside the square root symbol, you have negative 16, and that means 16 times negative 1 there. And so the next line will be 16 minus, this is where we split it, 16 times the square root of negative 1 there. And so this will give us 16 minus square root of 16 is 4. Square root of negative 1 is the imaginary number. All right, so this is the equivalent there. So the simplified version is 16 minus 4i. And we shall verify that from here, okay? You can see the red answer, so we're there. 16 minus 4i. Now, you cannot add anymore the real number and the imaginary number. That will be two separate terms there. So that goes to our number 11. We shall proceed to number 12. Let's have number 12. Here's number 12. Simplify negative 24 plus or minus square root of negative 9. So the real number part is the negative 24. That's the real number part of the complex number. Then we have plus or minus square root of negative 9. The square root of negative 9 is the part that will be the imaginary part of the complex number. So we have here negative 24 plus or minus square root of 9 times negative 1. There. Negative 9 can be factored to a 9 and a negative 1. So this is negative 24 plus or minus square root of 9 times the square root of negative 1, which can be further simplified negative 24 plus or minus 3i. There. So the answer is negative 24 plus or minus 3i. Okay, so this is now our complex number. Let's see the answer. Okay, over there, it's negative 24 plus or minus 3i. Okay, that confirms our answer there. Let's continue with the next. I hope you're getting the way to do it. We shall be able to see how it's done. Okay, and let's have number 13. Okay, number 13 now. Number 13 is here. Simplify 16 minus square root of negative 169. So we have here exact square roots. 169 has a square root of 13. So we will start with the real number 16 minus the square root of negative 169. And this is equal to 16 minus, you can now split the negative 169 to two numbers, 169 and multiplied by negative 1. There. That's the equivalent of negative 169. And so we can now have the two square roots, the square root of the 169 multiplied by the square root of the negative 1. And this is now 16 minus 13i. There. The square root of 169 is 13. And the square root of negative 1 is I. So the equivalent simplified to this. And we can check it over here. So you have there 16 minus 13i. Okay. That gives us the confirmation, and that's it. We're correct. And we shall continue with the next number 14. Let's consider the next one. Let me clear the screen. Okay, let's continue with number 14. All right. Here's number 14. We have a real number 2.6 plus the square root of a negative 81. Okay, we shall write the problem first. We're given 2.6. So this is a decimal number. So that's another real number. So that will be considered real part. Then we have here the square root of the negative number. That will give us the imaginary. So this is equal to 2.6 positive plus square root of 81 multiplied by negative 1 there. And so this is equal to 2.6 plus, we can now have two square roots here. The square root of the 81 multiplied by another square root of the negative 1 there. Don't forget the rule. The square root of a times b is equal to square root of a, square root of a, square root of a times the square root of b there. So if you have three factors inside, say square root of x times y times z, that means you can split this to three square roots. Square root of x times square root of y times square root of z. Okay, so these are the rules. That's why we're using 81 and negative 1 in two square roots. Okay, that's why we have this and this. Okay, coming from this one. We're following these rules here. Okay, all right. So let's continue. Let me just erase my formulas. Let me erase the formulas here so that we have some space to write on. I hope you were able to get that part. Let me remove the checks. Okay, let's continue. All right, so this is now 2.6 plus 9. And then the square root of negative 1, you know that very well. That's imaginary there. So the answer is 2.6 plus 9i. And we shall verify that after a short while over here. Okay, so yeah, 2.6 plus 9i. There. That goes to our number 14. So we're correct. All right, let's consider the next one. Let's have number 15. All right, number 15. Let me remove the answer. Let me continue with number 15. Okay, now we're going to use now the things we learned in the first part. Okay, I'll show you. This is the way to do it. All right. So this is I cube. Okay, we already discussed this a while ago. I is I squared is negative 1. I cube is negative I. Okay, because that's the product of this. So that means I times negative 1. Okay, so that means I cube is negative 1 times I. So that's why the answer is negative I. Okay, so the answer is negative I. There. The answer is negative I. All right, let's proceed to number 16. Let's have the number 16 there. Okay, how about I5? Okay, how about I5? All right. So you have I, that's equal to I squared is negative 1. Okay, I cubed is negative I to the fourth is a positive 1 because I to the fourth, okay, I to the fourth is I squared. Okay, why? I to the fourth. So we're going to repeat the things we discussed in the first screen. I to the fourth is I squared times I squared. So that means negative 1 here times negative 1. So negative 1 times negative 1 in algebra, that's positive 1 there. Okay, so now we need I to the fifth. Okay, what is I to the fifth. Okay, that means I to the fourth times I. Okay, I to the fourth times I. There. And so we have I to the fourth. That's positive one. It's over here. Positive number one. Okay, so this is 1 times I. And I to the fifth is simply I. There. That's the equivalent of I to the fifth. Okay, so you should be able to see the pattern. It's always by 4. Okay, I to the 1, I to the 2, I to the 3, I to the 4, I to the 5, I to the 6, I to the 7, I to the 8. And this will have a pattern. Okay, for the first 4, that is I, negative 1, negative I, positive 1. So going to the next 4, okay, it will be the same. I, and then negative 1, and then negative I, and then positive 1. So it's every fourth, okay? Every fourth, all right? So that will be cyclical, okay? It's a cycle, all right? So you only need to determine the pattern and uh, which number is the first, the second, the third, and the fourth, okay? So if it's like to the fifth, that means that falls to the first, okay? And so I to the fifth is supposed to be I, okay? And we shall verify the answer over here. All right, over there, you can see the answer, okay? All right. Later, we will have more slightly complicated than this one. All right, let's continue with the next. For a while, you have to remember the table, okay? It will be I, negative 1, negative I, and positive 1. Okay, that's the first 4. The rest are by 4s. Okay, always by 4. All right, so let's continue with next. Let's have number 17. Okay, we have here I to the 9. Okay, the ninth will be belonging to the first. Okay, all right. You can enumerate the table. You can enumerate the table, and you will find out. Okay, you will find out. All right. So if you have, if you can count the powers, okay, I to the first, I to the second, I to the third, I to the fourth, okay, that will be the first 4. Okay. Now the next 4 will be I to the fifth, I to the sixth, I to the 7, I to the 8. That will be the next 4. Okay. And then the next 4 will be I to the 9, I to the 10, I to the 11, I to the 12. That will be the next 4. For all this, you will have a cycle. Okay. This will have the I. This will be negative 1. This is negative I. This is positive 1. Okay. The next 4 will be the same. I, negative 1, negative I, and then 1. So the next 4 will be the same. I, negative 1, negative I, and positive 1. All right. So we can very well see I to the 9 must be another I again. There. Okay. And so this is equal to I. The answer here is I. There. Okay. It's imaginary. Okay. All right. Let's go to the next. Let's clear the board and proceed to number 18. All right. Let me clear the answer, proceed to number 18. Okay, I to the 8, that's a positive 1, of course, okay, from what we did a while ago. Okay, that's a positive 1. Okay, I to the 1, I to the 1, I to the 2, I to the 3, I to the 4. This is the first 4. Okay, I to the 5th, I to the 6th, I to the 7th, I to the 8th. This is the next 4. For the first 4 powers of I, this is imaginary negative 1, negative I, and this is positive 1. The next 4 will be starting again with I, followed by negative 1, and then negative I, and positive 1. Okay? All right? Okay. So what do you think is I to the 8? I to the 8 is, of course, positive 1. There. Okay? I to the 8 is positive 1. You can very well show that. I to the 4th, okay, squared. That's I to the 8th, okay? But I to the 4th from here, that's positive 1. Positive 1 squared is positive 1, okay? So I to the 8th is positive 1. There. And I to the 8th is positive 1. How about if it's a large number, okay? We will find out. Okay, let's have the next. How about I to the 12? Okay, I to the 12. So I to the 12 is also divisible by 4. Okay, divisible by 4. Okay, and so I to the 12 will also be a positive 1. So the rule goes like this. Because this is powers of I to the 1, I to the 2, I to the 3, I to the 4. We know that's in this particular order. I, negative 1, negative I, and positive 1. Okay. The next exponents 5, 6, 7, 8. 5, 6, 7, 8. That will have the same output there. Okay. Starting with I, followed by negative 1, followed by negative I, and the positive 1. Okay. All right. So you can just imagine the next. So you will have 9. Okay. 9, 10, 11, and 12. There. And this will have the same cycle I, negative 1, and negative I, and positive 1. So you can very well see that I to the 12 is positive 1. Okay, I to the 12 is positive 1. There. Okay. What if the number is very large? If the number is very large, you only need to divide by 4. Okay. If the remainder is 0, okay, if the remainder is 0 after dividing by 4, that's a positive 1. Okay. It's like 4 divided by 4. Okay. That's remainder 0. Okay. I to the 4 is 1. Okay. All right. How about I to the 8? I to the 8. I to the 8, we can take the 8 divided by 4. That will be again remainder 0. Okay. So each time you divide by 4 and the remainder is 0, that means the answer is 1. Okay. That is true. So this is I to the 12, and the answer is 1. There. So imagine if your number, if the exponent is divisible by 4 exactly, then it falls here. There. It's 1. If it's 8, that's also 1. If it's 12, that's also divisible by 4 with remainder 0. That will still be 1. There. Okay. Now, how do you get the other, like I, -1 and -I? If there's a remainder 1, then it's I, okay? If there's a remainder 1, that's I. If there's a remainder 2, then it's -1. If there's a remainder 3, then that's a negative I there. There's no remainder 4 because that will be equivalent to exact divisibility. Okay, so if it's divisible by 4, then that's a positive 1, like the numbers we have here, there and here and the 12. Okay, so you only need to remember the remainder when you divide the number. So you can now very well determine what is I to the 13. What is I to the 13? If you divide 13 by 4, okay, that will be 3 with a remainder 1. Okay, so 13, you divide 13 by 4. Okay, if we divide this, that will give us 3 in the quotient, but there will be a remainder, of course. This will have a 1 over there. Okay, if the remainder is 1, then that falls for the I. Okay, all right. Let's have I to the 13. That's already I, like that. Okay, all right. How about I to the 14? That means we're going to divide 14 by 4. Okay, we're going to divide 14 by 4. All right, let's do that. Okay, let's not erase the screen. Okay, we will just erase our writings over here. All right. What if we're asked to get I to the 14? I to the 14. Take note of the 14, and then you divide and take note of the remainder. All right. Okay, I will divide 14 by 4, and we're going to have another 3. Our quotient is 3, and then we proceed with the procedure on how to continue the division. 3 times 4 is 12, with a remainder of 2. There. Now we take note of the remainder. We take note of the remainder. It's 2, okay? That means that falls under the -1 there, okay? That falls under the -1. And so the answer for I to the 14, that's a -1, okay? That's a -1, okay? So I to the 14 is -1, okay? You can even write a chart like this, okay? The answer for I to the 14 is -1, okay? How about I to the 15? Let's do the other questions, okay? All right. Let's continue with another screen. I think I to the 15 is one of the examples, so let's just continue there. But I to the 12, here's the answer, okay? I to the 12 is 1, okay? Because it's part of the fourth, okay? It's part of the fourth in the cycle. All right, so I hope you were able to get that. Let's continue with the next number. Let's have number 20. Okay, number 20 has the I to the 15, okay? I to the 15. And so we need to determine, okay, the simplified value of I to the 15 and then multiply that by the real number 8, okay? So if you're going to simplify 8 I to the 15, okay, you will just divide that exponent 15, okay? Divide that, okay? So you have 15, you divide 15 by 4, always divide it by 4 because you have that particular I and then -1, -I, and +1, okay? So you divide this by 4, you will get another 3, and then you have here 12, and the remainder here is 3. If your remainder is 3, okay, if your remainder is 3, it falls to the third, okay? Remember, we have a cycle, I, -1, -I, and +1, okay? Always 1, 2, 3, 4. If your remainder is 3, then it will have to be this. So that means it's negative I, okay? All right, that's the remainder. When you divide 15 by 4, the remainder is 3. So the equivalent of I to the 15 is negative I. So this is equivalent to I times negative I. We're multiplying it like that, okay? So that means this is negative 8I. There. And that should be our answer here. There, okay? Negative 8I. Okay, I hope you were able to get that particular concept, and you'll be able to answer something like this. Okay, let's continue with the next number. Let's have the 21st. All right, here's the 21st. Okay, this is now simplified 24 I to the 20. Okay, what is I to the 20? 20 is divisible by 4, exactly, with the remainder 0. Okay, if it's divisible by 4 with the remainder 0, of course, that is positive 1. Okay, positive 1. So this will simply be, okay, 24 times 1. And this is equivalent to 24. There. That should be the answer. Okay. All right. Let's verify. There. The answer is 24. Okay. How did you get 1 for I to the 20? Of course, you divide exponent 20 by 4. Okay. Let's have the solution. If you divide 20 by 4, we get a 5. The quotient 5 is not important. It's the remainder, okay? We're after the remainder. So this is 5 times 4. We get a 20, a remainder of 0 there. Your remainder is 0. And if the remainder is 0, it falls to the fourth, okay? We know that the fourth gives us a positive 1, okay? So that means I to the 20 is positive 1. There. So we have 24 times 1 gives us 24. So the simplified equivalent of 24I to the 20 is just 24. And that's the answer. All right, that will be for 21. Let's consider the next. All right, I hope this is clear, and let's continue with the 22nd. All right, let's have the 22nd. Okay, here's 22. What is I raised to 255? Okay, all right. Here's what I'm talking about. All right, what if the number is so large? Okay, okay. Simplify I raised to 255. Okay, you will just divide, okay, and determine the remainder. So you have now 255. You divide this by 4. Okay, 25 divided by 4 is 6. 6 times 4 is 24. A difference of 1 there. Bring down the 5. We have 15 divided by 4. That's a 3. 3 times 4 is 12. We have the remainder. It's a remainder 3. Okay, where is 3 falling? All right, we have remainder 1, I. Remainder 2, negative 1. Remainder 3 is negative I. And of course, if your remainder is 0, that's a positive 1 there. All right, we have a remainder 3. Okay, that means we need this one here. Okay, so that's a negative I. All right, so I to the 255. Okay, I to the 255. You can split this. Okay, you can split this. All right, That means you have something like I to the 252, okay? And you have a remainder 3, right? You have a remainder 3. That means I to the 3 is there. 252 is divisible by 4, okay? 252 is divisible by 4, right? Okay. And the law of exponents, you can split it this way. There. I to 52, I to the 3. This should give you a 1, and that is I to the third. That's a negative I there. Therefore, 1 times negative I is negative I. So that means I to the 255 is negative I there. Okay? All right. That should be the answer. I told you 252 is divisible by 4. Okay? So you can try it here. 252, divide it by 4. Okay? You have 6 and you have 24. Okay, a difference of 1, bring down the 12, bring down the 2 to make 12. 12 by 4 is exactly 3. 3 times 4 is 12. This is 0. Okay, a remainder 0, a remainder 0 means 1. Okay, so that's why we have here the 1 there. So 1 times negative I, okay, because I to the 3 is negative I. All right, so that means 1 times negative I is another negative I. And we will be able to see the answer. It's over here. Let me clear the 63 here so you can see the I. There, okay? That's a negative I over there. That's the answer, okay? And that's our answer here. So you only need to divide by 4 and learn the method from the remainders, okay? From the remainders, okay? Simple as this. Let's have the next number. Let's proceed to number 23. Okay, let's consider number 23. How about I to the 1024? Okay, how about that? I to the 1024. How about that? Okay, I to the 1024. Let me clear the screen there. I to the 1024. Okay, all right. So I to the 1024 will now be tested if it's divisible by 4. Okay, let's divide. Divide this by 4. So we have here 2. Okay, 2 and 4, that's 8. Difference of 2. Bring down the 2. That must be about, how much is that? 5. And then 5 times 4 is 20. And the difference of 2 now, 22 minus 20 is 2. Bring down the 4. And then 24 by 4 is 6. 6 times 4 is 24. We have a remainder of 0. 0 remainder. That means I to the 1024, I to the 1024 is positive 1. There. You can also show the solution. It's because 256, okay? We have 256 times 4 is 1024, correct? So we can show the solution. It's I raised to 1024 or 1024. In algebra, you can split the exponent to its factors, okay? Factors, all right. So you can write this like 4 times 256 or raised to raised to 256, like that. So this is something like I to the fourth, I to the fourth, okay, raised to 256, there. Because 1024 is a product of 4 and 256. But I to the 4 is positive 1, there. So positive 1 raised to 256, okay, your calculator will give you already a positive 1, there. So the answer here is, of course, positive 1, okay? And we will be able to verify that from there. Okay, so I to 1024 is I to the 1. So you only need to use your division by 4 and then take note of the remainder. Okay, take note of the remainder. All right, so that goes to our number 23. Let's have our last number. Let's have our last number. Okay. How about number 24? I raised to 361. Okay, I raised to 361. Okay, again, you need to divide this by 4. 361 divided by 4, that's 9. 9 times 4 is 36. Okay, bring down the 1, divide by 4, it's a 0. 0 times 4 is a 0. That means we have a remainder 1. And remainder 1 means I. Okay, remainder 1 means I. So I raised to 361, it's I. The answer is I. Okay, and that's it. There. That's the confirmation, and the answer is I. All right. That's the last number. I hope you were able to learn this portion of the complex numbers, and I hope you'll be able to use this in your activities. And this will be all for now. Bye bye.